can start. So very good afternoon to all of you. Welcome you all to this live session. And if you have any doubts and questions, you can try to post it. We also have got some of the some questions. I can try to explain those. The question number 1 is, what is the hetero-aldol reaction? You know aldol reaction. If you have ionizable aldehyde or ketone, for example, acetaldehyde, which can, the presence of, for example, acid, you get the enol, which can undergo reaction with another molecule to give the aldol. So this aldol reaction, all of you know well. What is a hetero-aldol reaction? Just you have to break the bond, carbon-carbon bond, then it goes back to the ionizable aldehyde and ketone. In other words, starting material, which is known as hetero-aldol reaction. For example, so two molecules of these acetaldehydes can undergo reaction to give aldol. So hetero-aldol means you break the carbon-carbon bond. You get the starting material. So this is known as hetero-aldol reaction. This is aldol reaction. So in other words, product to starting material. The second question is, explain the 6-membered chair-like transition state in aldol reaction. So let us take this enolate. For example, if you have the methyl ethyl ketone, so when you react with base, and you'll be able to form enolate. This enolate can be E-enolate or okay, let me write again, is gone. If you take ethyl methyl ketone, when you react with base, you'll be able to form two kinds of enolates. Metal. Now you have this side methyl substituent. You have the double bond. So this methyl group can be trans. So you'll be able to generate E enolate, or you can also can produce a cis enolate. Both you can form. For example, if you have this E enolate, when you react with acetaldehyde, for example, what can happen? It can undergo addition reaction. For example, if you react with acetaldehyde, you will be able to form a mixture of compounds, stereoisomers. For example, if you have the E enolate, this chair conformation, six-membered chair. So it can approach two ways. This is more favored because the other one your methyl group is here, this methyl will be here, and this hydrogen is here, and this hydrogen is here. So both ways you can write. If you write like this is a E enolate, and the aldehyde can approach like this. If it approaches like this, is more favored comparing to that, because there will be a steric repulsion between this methyl group and this methyl group. Therefore, this is unfavored. This six-member transition state is unfavored. On the other hand, we form this one. This is more favored comparing to that. Now, it can undergo addition reaction with aldehyde, and you will be able to form this compound. Yeah, the OH, if you see the relationship between this hydrogen and this one, both are axial, that means they are trans. So this is equivalent to this compound. You get the anti-stereochemistry. We look at here, both are anti. On the other hand, if we have this enolate, for example, this Z enolate, what can happen? You can try to draw a similar way. Yeah, new page, yes. It will be, yeah. If you have the Z unolate, you can try to draw the transition state as earlier, and you will be able to have this 6-member transition state. And this is more favored. This is your methyl group. This is favored. You can also have other this is less favored, as just we have seen there will be a steric hindrance between this methyl group and this methyl group. Therefore, this 6-member transition state is favored. Then you can try to draw the product. You'll be able to have can you bring it back, that one? So now if you look at the relation between these two hydrogens, one is axial and equatorial, that means cis, which will be equivalent to so in this case you get the syn stereochemistry. So if you have the Z enolate, you'll be able to end up with a syn product. On the other hand, if you have the E enolate, you'll be able to have anti stereochemistry as the major product. The next question is, explain the acidity of active methylene compounds. Can you move the next slide? Let us look at this ester. Now you look at here, this is the electron withdrawing group. So this hydrogen is acidic due to the electron withdrawing nature of the substituent. We have another electron withdrawing group. Now let us take this one. You have two electron withdrawing groups, so therefore this hydrogen is more acidic, this methylene hydrogen. Is more acidic compared to that. Therefore, when you have the electron withdrawing group, the acidity of the hydrogen can be enhanced. The next question is when ortholithiation occurs. Whenever you have a chelating group, for example, take anisole. So when you react with n-butyl lithium, for example, the lone pair can now react and you will be able to have this intermediate which can convert into lithiated compound, and where you generate butane as the byproduct. So whenever you have the chelating group like oxygen or nitrogen, let us take this example. So this also similar way can undergo reaction, and when you treat this compound with the n-butyl lithium, similarly the nitrogen lone pair can make chelation with this n-butyl lithium and you will be able to form which can be stabilized by the nitrogen lone pair. Whenever you have the chelating group like imine, amide or the ether, they can try to assist and you can try to make the ortholithiation. The another question is explain side selective ring opening in Favorsky reaction. Can you change the slide? For example, when you take this ketone, which has Cl at the this carbon atom, this compound when you react with, for example, sodium ethoxide, it can deprotonate this can lead to the formation of carbon ion, which can undergo further reaction, substitution reaction to give the bicyclic ketone. Once you form this one, now you can see here three-membered this ring, more reactive, which can further undergo reaction with methoxide which can open up to give carbon ion, which when you do the workup, you will be able to get the ester as the product. So regarding this assignment number 1, question number 3, 6, 9, we will try to answer the next live session. Can you check any questions have come now? How do you check? Can you check any questions have come now? How do you check? Can you check any questions have come now? How do you check? Can you check any questions have come now? How do you check? So can you show the assignment 1? You don't know. No? But anyway, later maybe next live session we will check. But I don't have the data which they are asking some questions. Anyway, maybe next live session will be there. The student will be there. And we will be able to. So can you show the assignment 1? You don't know. No? But anyway, later maybe next live session we will check. But I don't have the data which they are asking some questions. Anyway, maybe next live session will be there. The student will be there. And we will be able to. So can you show the assignment 1? You don't know. No? But anyway, later maybe next live session we will check. But I don't have the data which they are asking some questions. Anyway, maybe next live session will be there. The student will be there. And we will be able to. So can you show the assignment 1? You don't know. No? But anyway, later maybe next live session we will check. But I don't have the data which they are asking some questions. Anyway, maybe next live session will be there. The student will be there. And we will be able to. So can you show the assignment 1? You don't know. No? Okay, so I am fine. How are you? And you should see the website to know what is NPTEL. The spelling is wrong, not NPTEL.
Maybe next year
NPTEL.
the student will be there. So can you show the assignment one? You don't know.
Okay, please visit our website. How are you? And you should see the website for education to know what is where you can get the detail. The spelling is wrong, not NPTEL.
Maybe next year
NPTEL.
the student will be there. So can you show the assignment one? You don't know.
National Program Technology please visit our website. How are you? And you should see the website for education to know what is where you can get the detail. The spelling is wrong, not NPTEL.
Maybe next year
NPTEL.
the student will be there. So can you show the assignment one? You don't know.
National Program Technology please visit our website. How are you? And you should see the website for education to know what is where you can get the detail. The spelling is wrong, not NPTEL.
Maybe next year
NPTEL.
the student will be there.
So what I want to tell you, please visit our Center for Education Technology, where you can find the details of all the courses and whatever you have written. Right. NPTEL is right. So if you see the website, there will be whatever we are having now video course and principles of organic synthesis, and you will be able to get. Okay, good. So you will be able to get a lot of courses, and please visit the website. No, see, this is a program where a lot of courses are there. So you will be able to, it's free, you can go to the website, you can try to learn. For example, chemistry, there are so many courses are there. You can try to take these courses and they are free. No, if you want to have more details, please write to, there will be a contact address will be there, you can write to them, they will explain to you. No, no, you have course on basic science also. Science, it covers a lot of, you have to go to the website, you will be able to understand engineering, science, there are a lot of subjects are covered. Okay, bye. If no more questions, let us conclude here. We will try to connect the next live session. Thank you. Bye.